surface of your B cell. So this is what we call presenting. This is an antigen presenting cell because there's the antigen. It is presenting it as a cell surface. Then the T helper cells recognize that, bind to that, and then one outcome would be the B cells turning into a plasma cell and making antibodies. Picture. This is, okay. That's going to be your white blood cell. Here's your microbe with the antigens. White blood cell engulfs that microbe. The antigens stay intact. The antigens bind with the major histocompatibility complex. That complex goes to the surface. A T helper cell has a T helper cell receptor right there. That's where it's going to bind. And that will trigger the cascade of events in your immune system. T cytotoxic. T cytotoxic induces apoptosis. So it's cytotoxic. These cells are going to be toxic to whatever pathogen you have. Look at it that way. Perforating granzymes, those are going to destroy the cell membrane. This is how T cytotoxic works. This virus infected cell, endogenous antigen. What that means, you got a virus, it stayed dormant for a while. But your cells still have that antigen for that virus, right? So, that's why it's endogenous. Here are your major histocompatibility complexes. This is complex 1. Complex 1 deals with endogenous, complex 2 deals with something that you just got. So the antigens are within your cell. Your cells have been infected and they've been dormant. Those antigens go to the surface, and then cytotoxic T cells will bind to that and destroy the cell. The difference between MHC1 and MHC2, MHC1 is endogenous. You had this infection already. Antigen presenting cells, when it does this thing, that's presenting the antigen. Natural killers, they don't need to see that little major histocompatibility complex. They just seek and destroy. So they're going to destroy anything that's infected with a virus, tumor cells, parasites, whatever. They just poke holes into the membrane and destroy whatever the pathogen is.
Do they lyse the cell?
Yeah. Okay. 3 main interleukins here, 1, 2, and 12. 12 inhibits humoral, so it inhibits the B cells, but it ups the T cells. Interleukin 1 is going to stimulate the T helper cells, but interleukin 2 will proliferate T helpers and activate the killer, the natural killers. Chemokines induces the migration of leukocytes. That means it causes the white blood cells to move through your body. TNF-alpha, we already saw that with the endotoxins. Hematopoietic, you have differentiation of your stem cells. And interference alpha, beta, again, viruses, gamma, bacteria. You don't understand this one. This one is easy. Are you okay with this one, or you want me to explain this one? You okay with this one? Sure, all right. I think that's it for. Okay, I think you're page 17. Let's go on to 20. 20 did a lot of drugs. I don't need you to know them individually, but group them together, group their mechanisms together. You understand this? Fleming discovered penicillin, but Florey and Chain actually worked on it, they tested it. Broad spectrum, narrow spectrum, you understand the difference, right? You know the difference between silent and static? Know this slide. The table was just a table of this slide. All right, penicillins. Understand your penicillins, whether natural, semi-synthetic, they're going to have the common nucleus with the beta-lactam ring. That's the active part of them. Now, this extra group out here, once you modify that, you can modify, is it injection or is it oral? So that's the part that can differ. Same here. Same common nucleus, same beta-lactam ring. But once you modify the outside, this is narrow spectrum, and this would be extended spectrum. Obviously, if you want to destroy penicillin, use penicillinase. Or what's another enzyme? If penicillinase destroys penicillin, what enzyme will destroy the active part there? So beta-lactam ring, so use beta-lactamase. Now, sometimes you need to pair them together. If you're going to take a penicillin, you have to take a penicillinase-resistant penicillin. Or you might have to take a beta-lactamase inhibitor. But understand that those are the enzymes that can deactivate your penicillin. Carbapenems, monobactams, they also have beta-lactam rings. Let's see, cephalosporins, they have a beta-lactam ring. It's slightly different though, but just let you know. So, cephalosporins, citrusine, vancomycin, they do inhibition of cell wall synthesis. However, if you have a mycobacterium, you need to take an anti-mycobacterial drug. Because where is the mycolic acid? Where's mycolic acid found? In the cell wall. So yeah, you are inhibiting the cell wall synthesis, but you have to take an anti-mycobacterial. To inhibit protein synthesis, know the mechanisms. You can bind to the